Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing Illustrative Math, Grade 8, Unit Number 5, Lesson 7, Practice Problems. Our first question here says, the equation and tables represent two different functions. Use the equation b equals 4a minus 5 in the table to answer the questions. The table represents c as a function of a. When a equals negative 3, is b or c greater? Well, when a equals negative 3, c equals negative 20, but b equals 4 times a minus 5. B equals 4 times 3 is negative 12. Negative 12 subtract 5 is negative 17. And C equals negative 20. Which is greater? So we want the greater number, which is negative 17. Negative 17 is greater than negative 20. Okay, when C is 21, what is the value of A? So when C is 21, what is the value of A? The value of A, when C is 21, A is 5. What is the value of B that goes with this? So now, if a equals 5, we have to use the equation to figure out what b goes with an a of 5. So b equals 4a, but a is 5, minus 5. b equals 4 times 5 is 20, minus 5 is 15. So what value of b goes with this? 15. When a is 6, is b or c greater? When a is 6, is b or c greater? Ooh, I don't see an a of 6 on here. We're going to have to think about this a little bit. Let's check b. When a is 6, for a of 6 minus 5, b equals 4 times 6 is 24, minus 5 is 19. So b is 19. C, 6 is going to be between this and this. Because at 5 we're at 21, at 10 we're at 19, which means at 6 we have to be somewhere in between these two values. So if we have to be in between 21 and 19 and b is at 19, which one is greater? That has to be C. C, because it has to be between 19 and 21. There was another one there. For what values of A do we know that C is greater than B? So where do we know that C has to be greater than B? When A is negative 3, B is greater. When A is 5, C is 21 and B is 15. A of 0, C is 7. and B is... So let's just go through and do all of these. At -3, who's greater? At -3, B is greater. At 0, who's greater? This one's 7, and the other one is 4 times 0 is 0, minus 5 is -5. At 0, C is greater. At 2, C is 3, and 4 times 2 is 8, minus 5 is 3. So they're equal to each other. At 5, A of 5, C is 21, and B is 15. At 10, C is 19, B is 4 times 10 is 40, minus 5 is 35, which is way more than that, so B is greater. At 12, 12 times 4 is 48. Minus 5. 48 minus 5 is 43. So that means C is greater. At 12. For what values of A do we know that C is greater than B? 0, 5, and 12? Okay, what's next here? Elena and Lynn are training for a race. Elena runs her mile at a constant speed of 7.5 miles per hour. The total distance is recorded every minute. Or Lynn's total distance is recorded every minute. Who finished their mile first? So, Lynn finished the mile in time, 9 minutes. Elena, her distance is 7.5 times the number of hours. So if we want their distance to be 1, so now how would I get this h by itself? Divide by 7.5 divided by 7.5. So h equals 1 divided by 7.5. 1 divided by 7.5 is 0.13 repeating. 0.13, and the 3 is repeating. But that's hours. This is in minutes. How many minutes is 0.13 repeating hours? 0.13 repeating. How many minutes in an hour? 60. Ooh, that's 8 minutes. 0.13 repeating hours is 8 minutes. Who finished their mile first? 8 minutes is faster than 9. Elena. Here's a graph of Lynn's progress. Now, we know They both started at the same time, and we know Elena finished it in 8 minutes. 1 mile in 8 minutes. Draw a graph. This would be way easier with a ruler. All I need to do is connect there to the origin. Pretend that's straight. And we're good. For these models, is distance a function of time? For every time, is there exactly one possible distance? Yes. Is time a function of distance? So, for every distance, is there only one possible time? Also, yes. If we look at a distance of 1 mile, that has to take this person 9 minutes. It has to take this person 8 minutes. Okay, match each function rule with the value that could not be a possible input. So which one of these values could not be possible? 3 divided by the input. Well, you can't divide by 0. So that one's 4, which is 0. You can't divide by 0, so you can't have 3 divided by 0. B, add 4 to the input, then divide this value by 3. Add 4 to the input, then divide this value into 3. So, is there something that if you add 4 to would make 0 so that you can't divide by 0? What's negative 4? Because negative 4 plus 4 is 0. So that's 3, which is negative 4. Subtract 3 from the input and then divide this value into 1. What number can you not subtract 3 from and then get 0? Well, that's positive 3. 3 subtract 3 is 0, which is 3. Okay. Find a value for x that makes this equation true. We all love solving equations. So what are we going to do first? I see parentheses, so let's distribute. If I'm going to distribute, all I've got here is a negative sign. What am I going to distribute? Well, if there is no number there, it is implied that the number is 1. Negative 1 times negative 2x is positive 2x. Negative 1 times 1 is negative 1. So all we really did by multiplying by negative 1 is flip the sign of that and flip the sign of that. Equals 9 minus 14x. Okay, now let's get all the variables on the same side. Which side has more? Well, 2 is more than negative 14. So let's get rid of the negative 14. To get rid of subtracting 14x, we add 14x, do it to one side, do it to the other. Those cancel. 2x plus 14x is 16x. Minus 1 equals 9. Now what do I have to do to get the x's by itself? Well, I got to get rid of this subtracting 1. So I'm going to add 1, do it to one side, do it to the other. Those will cancel. 16x equals 9 plus 1 is 10. 16 stopping the x from being by itself. They're multiplied. To undo multiplying, we divide. Do it to one side, do it to the other. X equals 10/16. Both of those are even. So I'm going to call that 5/8. Okay, I think that was the last one. Yep, Okay, this has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.